Welcome back. Today, we are tackling one of the most critical roles in modern tech, the application security engineer and DevSecOps lead. We've analyzed job descriptions from major tech companies and healthcare platforms to build a super candidate interview. We are covering the real deal: how to architect secure pipelines, handle vulnerability triage without burning out developers, and secure cloud infrastructure. I have 30 deep dive questions prepared. I've stripped out the complex code syntax so you can focus on the concepts and the logic you need to speak to confidently. If you're ready to master the shift left mindset, hit that like button. It helps us reach more security pros. And subscribe so you don't miss our upcoming system design series. Let's get into the interview.
We want to implement DevSecOps as a service. How do you integrate security without slowing down the developers?
The goal is frictionless security. I don't want to be a blocker at the end. I want guardrails throughout. My strategy is simple. 1. IDE level. I give developer plugins that catch issues while they are typing code so they fix it instantly. 1. Pull requests. We run fast security checks on every pull request. If a check fails, it stops the merge, giving immediate feedback. 1. Async scans. Heavy, slow scans happen after the build or overnight. We never block a deployment pipeline unless it's a critical, confirmed vulnerability.
Walk me through a standard pipeline security architecture. What tools go where?
I visualize it in stages. 1. Pre-commit. We scan for hard-coded secrets before code even leaves the developer's laptop. 1. Build stage. We use SCA, software composition analysis, to check open-source libraries for known vulnerabilities. 1. Test stage. We run SAST, static analysis, to scan the source code patterns. 1. Deploy stage. We run DAST, dynamic analysis, against the running application to catch runtime errors. 1. Infrastructure. We scan the infrastructure templates, like Terraform files, to catch misconfigurations.
You turn on a scanner and it flags 5,000 issues. The developers are furious. How do you handle this?
I never turn on block the build immediately. First, I run the scan in audit mode to establish a baseline. Then, I manually review the results to tune the rules and filter out the noise. Once the noise is gone, I only block builds for high or critical confidence issues. Everything else goes into the backlog as technical debt to be fixed later.
A critical vulnerability is announced in a library we use. How do you find every app using it?
This is why centralized SCA is vital. If we have a modern tool, I can just query the dashboard for that specific package version. If we don't have that, I would write a script to scan the dependency files, like or, across all our repositories to generate a hit list for remediation.
We are moving to Docker and Kubernetes. How do we secure the images?
We need to secure the supply chain. 1. Trusted base. We use minimal trusted base images to reduce the attack surface. 1. Scanning. We scan the image for vulnerabilities during the build process. 1. Signing. We cryptographically sign the image. The production cluster is configured to reject any image that doesn't have a valid signature from our pipeline.
Developers keep hard-coding API keys. How do you fix this architecturally?
We need to move to a secrets manager. The application should retrieve the secret programmatically at runtime using its identity, rather than reading a hard-coded string. For the developers, I provide a template for a local environment file that is ignored by Git, so they can test locally without accidentally committing secrets.
You receive a bug bounty report claiming a critical SQL injection. What are your steps?
1. Validate. I try to reproduce it myself to see if it's real. 2. Assess impact. Is it actually exploitable? Can I extract data? Or is it just an error message? 3. Prioritize. If it's valid, I mark it as critical. 4. Fix. I work with the developer to implement a proper fix, like using parameterized queries, rather than just a quick patch.
Our policy says criticals must be fixed in 24 hours. A team misses the deadline. What do you do?
I check first. Is it complex? Do they lack resources? If they are just ignoring it, I implement controls. I might temporarily block their ability to deploy new features until the security debt is paid down. However, I prefer to offer office hours to help them fix it, rather than just punishing them.
What is the most common API vulnerability you see today?
BOLA, Broken Object Level Authorization. This happens when I can change an ID in the URL, like changing user ID 100 to user ID 101, and access someone else's data. Automated tools often miss this because it looks like a valid request. I test for this manually by creating 2 different user accounts and trying to cross-access data.
Running DAST scans in production is risky. How do you do it safely?
We never run destructive tests, like heavy fuzzing, in production. We run the deep scans in the staging environment. For production, we only run passive or safe checks. We also configure the scanner with a specific test user account so it doesn't accidentally delete real customer data.
Explain the difference between XSS and CSRF to a junior developer.
XSS is when the attacker runs their malicious script in browser to steal your session. CSRF is when the attacker tricks your browser into making a request you didn't intend, like sending money, because you are already logged in. We fix XSS by sanitizing input. We fix CSRF by using unique tokens on every form.
How do we prevent a supply chain attack in our build pipeline?
We need to verify the integrity of the build. We use ephemeral build runners, servers that spin up for one job and destroy themselves immediately after, so no malware can persist. We also pin our dependencies to specific hash digests so the code never changes without us knowing.
We use Terraform. How do we ensure the infrastructure is secure before it's deployed?
We treat infrastructure code just like application code. I would integrate a scanner like Checkov into the pipeline. For example, if a developer writes code that sets a database to be publicly accessible or turns off encryption, the scanner detects that logic and fails the build automatically.
Our developers want full admin access because IAM is too hard. How do you handle this?
I enforce least privilege. I use tools that analyze their actual activity in the development environment. If they only used S3 and Lambda, I generate a policy that allows only those actions. I also use permission boundaries to ensure they can't create new admin users for themselves.
We are deploying a multi-tenant app on Kubernetes. What are your top controls?
1. Network policies. By default, I lock down the network so different services cannot talk to each other unless explicitly allowed. 1. RBAC. I restrict who can run commands on the cluster. Developers usually get read-only access in production. 1. Pod security. I enforce standards that prevent containers from running as root or accessing the host system.
Someone manually changed a firewall rule in the console. Terraform doesn't know. How do we catch this?
We need a drift detection tool. It monitors the live environment. When it sees a change that doesn't match our code baseline, it alerts us. Ideally, we have auto-remediation enabled that reverts the change back to the secure state immediately.
We are using AWS Lambda. We don't manage servers, so are we secure?
Not entirely. The code itself can still have vulnerabilities. The identity role assigned to the function might be overprivileged, and attackers can still manipulate the event data triggering the function. We still need to scan the code and lock down the permissions.
We are launching a public portal. How do we protect it from attacks?
We need a web application firewall, WF, at the edge. I would configure rules to block common attacks like SQL injection. I would also turn on rate limiting to stop bots from brute forcing our login pages.
We are building an AI chatbot. Walk me through a threat model.
I look for specific risks. 1. Spoofing. Can I pretend to be another user? 1. Prompt injection. Can I trick the AI into ignoring its safety rules? 1. Data leakage. Will the AI accidentally reveal private training data? We need strict validation on what goes into the model and a filter on what comes out.
Developers want to paste code into ChatGPT to debug. Is this okay?
No, that is a data leak. I would block public AI sites. Instead, we should provide a private, internal AI instance where we have a contract ensuring our data isn't used to train the public model.
I need a report of every repository that contains a credentials file. Can you script this?
Yes, I'd write a Python script. I would use the GitHub API to loop through all our repositories. For each one, I'd search for file names matching credentials. Then, I'd have the script export the list of matches to a CSV file for us to review.
We found our source code on a public GitHub repo. What do?
1. Takedown. Immediately file a request to remove the code. 2. Rotate secrets. Assume every key and password in that code is compromised. Change them all. 3. Forensics. Check our logs to see if those keys were used recently. 4. Root cause. Find out how it leaked and implement controls to stop it from happening again.
How does zero trust apply to AppSec?
It means never trust, always verify. Just because two services are on the same internal network doesn't mean they should trust each other. We use mutual authentication so every request is verified, regardless of where it comes from.
Our budget is blowing up because of duplicate reports. How do we manage this?
We need better documentation. If we know about a bug but haven't fixed it yet, we list it as a known issue so researchers don't report it. I also group similar reports. If 10 people report the same bug on 10 different pages, I treat it as one root cause and one payout.
A product manager wants to skip the security review to launch on Friday. What do you say?
I focus on risk acceptance. I say, I understand the deadline. I won't physically stop you, but I need you to sign this risk acceptance form. It states that you accept the liability for launching with these vulnerabilities. Usually putting their name on the risk makes them find the time to fix it.
How do you turn a developer into a security champion?
I make it rewarding. I find the curious developers and send them to advanced training. I give them special recognition and pre-approval rights on security changes. They become my eyes and ears inside the development teams.
The security landscape changes fast. How do you keep up?
I follow the major security blogs and the OWASP updates. I also practice and capture the flag events to keep my hands-on hacking skills sharp.
How do we measure if our program is working?
I look at time to remediate. Are we fixing bugs faster? I also look at pipeline block rate. If we are stopping builds too often, we are hurting velocity. And I track coverage. What percentage of our apps are actually being scanned?
Our devs work from coffee shops. How do we secure them?
We move away from IP whitelisting. We use a zero-trust access model. They authenticate via MFA, and we verify their device health, like antivirus status, before letting them access our build servers.
Do you have questions for us?
Yes. How is the relationship between engineering and security currently? Is it collaborative or is it adversarial? I want to ensure I can build bridges, not just firewalls.
And there you have it. 30 high-level questions covering the full spectrum of AppSec and DevSecOps. If you can confidently answer questions about pipeline architecture, cloud security, and threat modeling in this way, you are ready for that lead role. Which question was the hardest? Let me know in the comments below. If this video helped you prepare, please drop a like. It really supports the channel. And if you want to see a live demo of setting up these pipelines, make sure you subscribe and ring the bell. Thanks for watching, and stay secure.